Okay, so 10.3 is on properties of logarithms. So it says when we learned about exponents in chapter 1, we saw that to multiply powers with the same base, you add the exponents. In other words, a to the, what are those, m times a to the n equals a to the m plus n. You just add your exponents. Like x squared times x to the 5th is x to the 7th. And when we first talked about logarithms, I told you that they are exponents. They don't look like exponents, but they represent exponents. So the same concept holds. If you have multiplication, you have addition. So here's what the product property of logarithm says. It says the logarithm of a product. So if I had log with some base of m times n, it's equal to the sum of the logarithms of its factors. So it's going to be equal to log base b of m plus log base b of n. So a lot of people get confused on that, but basically it's just because of the exponential rules that we had before. Like if I had a to the m times a to the n, it was really addition for your exponents. So same kind of thing. What?
So that mn, that wasn't the exponent, like the exponential form.
It wasn't what?
That's not the exponent in the exponential form.
So these are exponents, and when you add them, so these are two are exponents, it was really multiplying. So when you combine them, I don't know. We'll do some examples. We'll check. Okay, so example 1, it says express log base 6 of 4 plus log base 6 of 9 as a single logarithm and simplify if possible. So I have log base 6 of 4 plus log base 6 of 9. So this rule goes backwards as well. So if I combine them, it's going to be log base 6 of 4 times 9 which is log base 6 of 36. Okay, and do you guys remember how we did this the other day? So what's log base 6 of 36? 6 to some power makes 36. What would you say? Yeah, like if we switched it, we said 6 to the x equals 36, right? If this was equal to x, 6 to the x equals 36. So what's x have to be then? No, not 6. 2, right. So that's where that came from. So your answer is 2. All right, so the next one, it says log base 10 of 25 plus log base 10 of 40. So expresses a single logarithm. So it's log base 10 of, since I have addition, I'm going to multiply. So I have log base 10 of 1,000. So 10 to some power equals 1,000. So what is that power? Nope, not 100. 10 times 100. 10 to the third, right? So it's 3. Remember, 10 to the third power equals 1,000. That's why that's happening. Remembering all this? All right, next up. Okay, so also when we learned about exponents, we said that to divide powers with the same base, we subtracted your exponents. So in other words, if I have a to the m over a to the n, it was a to the m minus n. So same thing with logarithms. If you have two logarithms that are subtracted, you really can combine them with addition. So it says the not addition, division. It says the logarithm of a quotient is the logarithm of the dividend minus the logarithm of the divisor. So if we have log with some base of m over n, I'm going to separate it. So it's going to be log base b of m minus log base b of n. Okay, so both of these are very important that you know. It's the quotient and the product property. Okay, so if I want to combine, in number 1, if I want to combine those two logarithms, it was subtraction before. So I'm going to combine with division. So it's 100 over 4, which is log base 5 of 25. So log base 5 of 25, can you do it in your head? 2, right. You say 5 to the second power equals 25. Okay, the next one. So if I combine into one logarithm, it's log base 7 of 49 over 7, which is log base 7 of 7. So 7 to some power equals 7, 1, right. Okay, next up. Okay, so let's talk about some other rules. So suppose you have log, this is base 10 because there's no number there, so log base 10 of 10 to the third power. That's really just log of 10 times 10 times 10. So based on that rule we just learned, if I have a logarithm with multiplication, I can separate it, right, into separate logarithms. So it's going to be log of what? Log of 10 plus log of 10 plus log of 10. Okay, this one's important. You guys see it? So see why we can do that? It's the product rule. You can break it up. Well, before, when you were first learning algebra, if you had x plus x plus x, how did we write that final answer? 3x, right? So I have 3 log 10s. So it's just 3 log 10. Yep. So this is what kind of blows everybody's minds about logarithms. If you have an exponent, so if you had 10 to the third like that, the 3 can really go to the front. So it's 3 log 10. Okay, very weird. All right, so it says if we have 3 of anything, we say it's 3 times that thing. In other words, we have 3 log 10. This is another property of logarithms. So here's how we would write it. So if I have log base b of, I don't know, x to the c, that c can just go to the front because it's like writing out log base b of c, or log base b of x, c times, added together c times. So it's just c log base b of x. You guys shut that door, please. Okay, number 1, express as a product, simplify if possible. Okay, so this is kind of putting everything together. So when you see that exponent, the first thing you want to do is bring it to the front. I don't want to figure out what 32 to the 6th power is. That doesn't look very fun. So bring it to the front. So I have 6 log base 2 of 32. Is there anything else you know how to do? 2 to the what? Yeah, 2 to some power makes 32. So 2 to some power equals 32. So what would that power have to be? Can you guys do that one in your head? 5. It's 5. So this whole thing is 5. So it's 6 times 5, which is just 30. So your answer is 30.
Wait. What happened to the 6? Wait.
It's there.
Not
Yeah.
there. I mean, like, so the 2x equals 32.
Oh, yeah, we're just doing that part in our head. A lot of this is mental math. Yep. All right, you guys try B. So try B. See what you get.
Like in real life application,
Uh-huh.
what are logarithms in real life?
They are very useful. So if we ever have some kind of equation where if I had like 2 to some power equals, I mean, it could be like any, it could be any 1, 3, 7, 2, 5, I don't know. Let's say we have that. If I wanted to solve, the only way I know how to solve is with logarithms. You don't want to keep putting different numbers in for your exponent to guess what that number is. Think about carbon decay. So have you guys talked about that in chemistry? So dating, like carbon-14 dating, logarithms. It's with logarithms, yep. What else? pH scale, logarithms.
A lot of chemistry. Do you have an answer?
Yeah. Miss Summit wants to tell you.
Anthony, you can use logarithms in a lot of chemistry, a lot of biology in terms of like if you're trying to figure out populations of like bacteria, let's say, where there's millions and millions and they're really small. You can use them in some construction, so different architecture type jobs.
I just didn't know.
Yep. We're doing lots of log activities in this chapter, so be prepared. You use them all the time. All right, so this one. So what do you do first? No guesses?
20 log 8.
20 goes to the front, right? So you have 20 times log base 8 of 64. So it's 20 times, what is log base 8 of 64? 2. 20 times 2 is 40. That's your answer. Okay, the next one, 10 goes to the front. So I have 10 log base 16 of 4. This is a hard one. Yeah, Anthony?
Is it 2.5?
2.5? Nope. I see how you got that though.
That's what I mean.
It's 5. So Kelsey, what'd you do?
Because it's like 1 like half make 4.
Yeah, it's 16 to the 1/2 power. It's the square root of 16. That's what gives you 4. So it's a 1/2, not a 1/4. So you get 5. So your answer should be 5. All right, how about this one? So pull the 6 to the front. I have log base 27 of 3. So Anthony, you want to redeem yourself?
Oh, yes, ma'am.
What's log base 27 of 3?
1/3.
1/3.
That swag, murder that swag.
6 times 1/3 is
2.
2. You got it. Okay, let me see where I'm at with time.